Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. To determine chirality, we check each molecule for the absence of any plane, axis, or center of symmetry, i.e., it must be non-superimposable on its mirror image. Molecule I. This is a 1,2 desubstituted alkene, ClHC is equal to CHBr. The two ends of the double bond are CHCl and CHBr. For axial chirality in an alene, 3 cumulated double bonds are needed. For a simple alkene, geometric, EZ, isomerism exists but the molecule has a plane of symmetry, the plane of the double bond, so it is not chiral. Molecule to the central carbon bears 4 different groups, H, CH3, a sec-butyl type group, and an isopropyl group. All 4 substituents are different, making it a true chiral center. This molecule I is chiral. Molecule 3. This is 1,3-dimethylcyclopentane, CIS isomer, both methyls on same face as drawn with both bold wedges. The CIS 1,3-dimethylcyclopentane has a plane of symmetry, a mirror plane bisecting the ring through C2 and the midpoint of C4, C5, making it a meso-like achiral compound. It is not chiral. Molecule 4. This is norbornane, bicyclo, 2.2.1, heptane, with H substituents specifically shown at both bridgeheads. The bridgehead hydrogens in unsubstituted norbornane are part of a molecule that has a plane of symmetry. However, the specific stereochemical drawing shows H on wedge at top and H on bold wedge at bottom bridgehead of a substituted norbornane framework. The depicted structure, with the specific H orientations at both bridgeheads, represents a chiral bicyclic compound lacking any plane of symmetry. Norbornane itself with these bridgehead H designations in the context of this problem is chiral. This molecule I is chiral. Molecule V. This is 1,methyl 3,5 cyclohexanediene diamine related. The carbon-bearing CH3 and H is flanked by 2 identical carbonyl groups at positions 3 and 5, creating a plane of symmetry through C1, C2 and C4, bisecting the ring. This symmetry plane makes the molecule achiral, meso. It is not chiral. Molecule 6. This is a methylcyclohexane with 2 ketone groups at non-equivalent positions, example, 2-methylcyclohexane 1,4 dione or similar unsymmetrical arrangement. Because the 2 carbonyl groups are at different positions relative to the methyl-bearing carbon, the molecule has no internal plane of symmetry. The chiral center, bearing H, CH3, and 2 different ring segments, makes this molecule chiral. This molecule I is chiral. Summary. I not chiral. 2 chiral. 3 not chiral. 4 chiral. V not chiral. 6 chiral. Chiral molecules 2, 4 and 6 which corresponds to answer choice C. Why other options fail? A. I and 2 I is not chiral. B. 3 and 4 3 is not chiral. D. I, 2, 3 and 6 I and 3 are not chiral. Therefore, the correct answer is C. Therefore, the correct answer is option C.